Okay, good morning. It's November 15, 2023. The time is what time? 3 o'clock. Okay, my topic for this morning will be a continuation of my subject matter Trigonometry, lesson number 23. And the title of the topic will be Trigo functions involving fractions and reciprocals. This is a continuation of the so-called study of identities of trigonometry. The last time around, I derived the three most important trigonometric identities under trigonometry. That is, one of them is number one is sine square of alpha plus cosine square of alpha is equal to 1. And the next one is 1 plus tangent square of alpha is equal to secant square of alpha. And the last one is 1 plus cotangent square of alpha is equal to cosecant square of alpha. So for this morning, I will be adding 5 more formulas in which these formulas are needed in the so-called evaluation of problems involving identities. Okay, let's proceed. The subject matter for this morning will be a long video format discussion, and the subject matter is trigonometry. And I am now on lesson number 23. So for those of you who are following my long video format discussion on trigonometry, we are now on lesson number 23, and the title of the topic will be Trigo functions involving fractions and reciprocals. This is an easy one, but it's the foundation of the identities under the study of trigonometry. Okay, let's try to bring out the 4 or 5 added formulas needed in the study of identities. We'll bring out the figure, same figure as the last time around. We are given a right triangle. The acute angle is alpha. This is A. This is side B, and this is the hypotenuse. To bring out the so-called equivalent of a fractional trigonometric function, actually there are only two. It's the so-called tangent or cotangent. So we will start with tangent. Tangent of any angle, tangent of any acute angle, considering a right triangle, will be the opposite side over the adjacent. Considering alpha, this is opposite, this is adjacent. And by definition, tangent is actually opposite over adjacent. Okay? It's A over B. We'll divide both the numerator and denominator by C. We could do that. What you will do on the numerator, you could do it on the denominator, it will not change the value of the fraction. So dividing both the numerator and denominator by the hypotenuse C, it will become A over C. All over, this is B over C. Right? We could do that. We divide the numerator by C, and so with the denominator, we do not change the value of the fraction. Then after that, what comes out is the ratio A over C and B over C. But what is the ratio A over C? The ratio A over C is actually sine. The sine of angle alpha is the ratio opposite over hypotenuse. So the ratio A over C is actually sine of alpha. How about the ratio B over C? The ratio B over C. It's actually cosine, right? So cosine of alpha, we represent B over C to be equal to cosine of alpha. Therefore, tangent of alpha, we replace the values of this in terms of sine and cosine. So tangent of alpha in general, for any acute angle in any right triangle, it will be sine of alpha over cosine of alpha. Meaning to say, if we are given the sine of an angle and the cosine of an angle, we divide those two numbers, and what will come out will be the value of the tangent of that angle. So in general, from now on, under the study of trigonometry, tangent of alpha is actually sine of alpha over cosine of alpha. Next one, cotangent of alpha. What's the definition of a cotangent? Cotangent, I better remove my eyeglass. I think my eyes are clear now. Cotangent of alpha is the ratio of adjacent over opposite. So this is actually B over A. And again, we'll divide both the numerator and denominator by the same hypotenuse C. So it will become B over C, and this should be all over A over C. But what is the ratio B over C? What is the ratio B over C? B over C is actually cosine, right? And what's the ratio A over C? A over C is sine. Therefore, in general now, cotangent of any given angle alpha should be cosine of alpha over sine of alpha. It's the reciprocal of this, right? So for tangent, it is sine over cosine, and for cotangent, it should be cosine over sine. Okay? We needed this one and the so-called problems involving trigonometry. Number 3, what's the definition of tangent? Tangent is still, tangent of alpha is still A over B, right? Same as this one. Okay? But to derive the next equation, or next trigonometric function, not same as this one, we will divide both the numerator and denominator by A. Okay, instead of C, it's by A. So it should be A over A all over, this is B over A. A over A is actually equal to 1. Right? So what will come out? It will be 1 over the ratio B over A. But if you try to go back to the resulting, to the given right triangle, the ratio B over A is cotangent. Right? B over A is cotangent. And here, we place B over A to be cotangent of alpha. Therefore, tangent of alpha now should be equal to 1 over cotangent of alpha. Tangent and cotangent are actually reciprocals, right? So tangent of alpha is equal to 1 over cotangent of alpha, or if we interchange, cotangent of alpha is 1 over tangent of alpha. Okay? That's the third formula. Next one. We'll take the cosine of angle alpha. Cosine of angle alpha, it will be, cosine is actually adjacent over hypotenuse, considering alpha, right? It should be the ratio B over C. Then, to derive the next equation, we will divide both the numerator and denominator by B. So this is small letter b over small letter b all over C all over small letter b. And small letter b divided by itself is actually equal to 1. So what will come out will be the ratio 1 over the ratio C over B. But from the given right triangle, what is the ratio C over B? C over B is actually secant. Secant of alpha is actually the hypotenuse over adjacent. So in general now, cosine of alpha will be 1. Okay, the equivalent of C over B is secant. 1 over secant of alpha. Okay, cosine and secant are actually reciprocal functions. Meaning cosine of alpha is 1 over secant of alpha, or if we interchange, secant of alpha will be 1 over cosine of alpha. Last one for tonight. This is an easy one. Number 5. We take the sine function, sine of alpha. Sine of alpha is the ratio A over C, right? Right? So sine of alpha is the ratio A over C. And to derive the next, what you call this, trigonometric function, we will divide both the numerator and denominator by A. So small letter a divided by small letter a all over C all over small letter a. And the ratio small letter a divided by itself is actually equal to 1. So it will now become 1 over C over a. But from the given figure, the ratio hypotenuse over opposite is actually cosecant. Okay? Therefore, cosecant of alpha, the equivalent is actually the ratio hypotenuse all over opposite. Therefore, we could replace this C over A by cosecant of alpha. Therefore, in general now, sine of alpha will be 1 over cosecant of alpha. Or if we interchange location, cosecant of alpha will be 1 over sine of alpha. This is formula number 5. Plus the other 3, the last time around, there will be 8 trigonometric functions, okay? That is needed in the so-called solution of problems involving trigonometric identities. Okay? Okay, that's it, guys. This is Professor David J. De Los Reyes. Good morning from Los Angeles.